What are we scientists doing to achieve conservation and sustainable fisheries of chondrichthyans in the Mexican Pacific? Hello, my name is Luz Saldaña-Ruiz. I'm a Mexican scientist, and my main areas of research are ecological risk assessment, vulnerability assessment of ecosystem, communities and marine species to various activities of anthropogenic origin, including fishing and oil spills. I also have specialized in biodiversity ecology, fisheries, and conservation of chondrichthyan species. I have a bachelor's degree in biology, a master's in science and natural resources and marine ecology PhD from the Research and Higher Education Center at Ensenada, Baja California, Mexico. I'm based in Ensenada, located in the Baja California Peninsula in the Northwest Mexican Pacific, one of the most productive ecosystems and the most important shark and rays fishery regions in Mexico. I grew up reading marine wildlife books, swimming in the sea, and spending hours in pools watching invertebrates and small fishes. The next logical step for me was studying to be a biologist, and during my studies, I found myself interested with chondrichthyan species. Due to economic and personal reasons, in my first years after the university, I couldn't work directly with this species. I worked in aquaculture projects for a while, but one day I took all my savings and traveled to talk with potential PhD supervisor, the best decision I ever made. My now former thesis supervisor and mentor, Dr. Sosa Nishizaki, was not expecting me, and he always said he had no other option than accept me as her student because I had a lot of courage to stand in his office door one day without an appointment. Since then, I did a PhD in marine ecology, and I finally have the opportunity to work and develop and lead many chondrichthyan fisheries-related projects, and has been and continues to be one of the best and more exciting years of my life. But enough about me. Let me tell you about some cool chondrichthyans conservation and fishery research in the Mexican Pacific. Chondrichthyans, including sharks, rays, and chimeras, are also known as cartilaginous species, belong to elasmobranch and holocephalic classes. They are aquatic vertebrates, mandibular, with a cartilaginous endoskeleton. In Mexico, there is a great diversity of chondrichthyan species with about 214 described species, of which 111 are sharks, 95 rays, and 8 chimeras. In the Mexican Pacific, the complex oceanographic features and large variety of ecosystems have led to a great fish diversity, including sharks. The Mexican Pacific extends from the north of the Baja California Peninsula to the Gulf of the Tehuantepec. And the Mexican Pacific, there is a highly variable bathymetry with depths of more than 2,000 meters, and in most of the exclusive economic zone of Mexico, and a maximum depth recorded off the coast of Chiapas and Oaxaca in the Tehuantepec pit of more than 6,000 meters. The Mexican Pacific encompasses 4 large marine ecosystems based on physical and biological characteristics, including the west coast of the Baja California Peninsula, where tropical and temperate conditions intermingle, known as the South of California Pacific, the Gulf of California between the peninsula and the mainland, the Mexican Transitional Pacific, where faunal composition varies seasonally, and the Gulf of Tehuantepec, which is tropical. The distribution of most shark species is predominantly influenced by temperature, limiting many geographic range. The Mexican Pacific has a diversity of 62 shark species, approximately 55% of the total shark species in Mexico, and this is 13% of the valid known shark species in the world. And the diversity of sharks in the Mexican Pacific is greater than in other regions in the world, such as the Mediterranean and the Northeastern Pacific, including the Pacific coast of Canada and the United States of America. The diversity of shark species in the Mexican Pacific is greater in the north, where a mixture of cold and warm temperatures occurs, and more than 80% of the species distributed in the Mexican Pacific can be found in the South Californian Pacific and in the Gulf of California regions. Due to this enormous diversity of chondrichthyans, it is not surprising that sharks and rays species have long been vital source of food and employment, with great cultural and social importance among coastal fishers in Mexico. Sharks and rays are caught by artisanal or small-scale fisheries with small vessels less than 10 meters in length, and industrial fisheries with vessels between 10 and 27 meters in length, either as a target or incidental, in coastal water, as well as in ocean waters within the Mexican exclusive economic zone, and represent a primary economic activity for many coastal communities. The artisanal fisheries are multi-specific with a high diversity of chondrichthyan species caught. Multiple fishing gears are used, like bottom and surface gill nets and bottom and surface long lines, and occasionally hand lines. Since the mid-70s, Mexican shark fisheries have been the largest in the Americas. Mexico is recognized worldwide as an exporter of shark fins, mainly to Asian countries, and Mexico is among the top 20 shark producing countries, and is in the top 10 sharks producing nations that export sharks to Asian markets. Sharks and rays are great cultural and social economic importance in Mexico, a source of income, food and jobs. And in 2019, a total of 46,000 of sharks or tons of shark and rays were landed. The main shark products are meat, fins, oil, skins, and cartilage. At the national level, we have high consumption of shark meat, around 45,000 of tons per year, and this is approximately that 36 per capita, kilograms per capita. Most chondrichthyan species have been described as vulnerable to overfishing due to their life history characteristics such as low fecundity, slow growth, late maturity, long gestation periods, and great longevity. This characteristic means that these species have low growth rates and therefore a slow recovery of the populations in the face of the intense fishing effort. In the red list of the IUCN, of the International Union for Conservation of Nature, IUCN, which systematically evaluate the relative risk of extinction of species, including sharks, about 70% of the sharks in the world are threatened. This means that they are listed in vulnerable, endangered, or critical endangered categories of the IUCN. In the Mexican Pacific, 27% of the sharks are classified as threatened, and another 25% of the species are data deficits, which means there is not enough information to evaluate, to assess the status of their population. International treaties have been proposed as a medium to contribute to shark sustainability. Among these is the Convention of International Trade, Endangered Species of Wild Fauna and Flora, CITES, and stand out as a tool to regulate the international trends of shark products and promote fisheries management through the emission of non-detrimental findings that support the sustainable use of sharks in each country implemented. 9 shark species have been listed in CITES that are commercially caught by Mexican fisheries. The common pelagic and big-eye treasures, oceanic white-tip, the silky shark, the shortfin mako, the scallop, the smooth, and the gray hammerhead. And there are also other sharks and rays listed in CITES, like several oceanic manta rays, the whale sharks, white sharks, basking sharks, and sawfishes, but they are protected by Mexican laws and their fishing is forbidden. Products from these species have different uses. The meat is used for national consumption as a sheep protein source and treasure, and shortfin mako meat is exported to USA. Fins are exported to Hong Kong, and the main exporter of fins from CITES species. also where Mexico is the main exporter of fins from sighted species and also from the top 10 shark nation. Mexico is the only one reporting fins from these species. Despite the importance of Chondrichthyan species, the population status of many species is unknown. And this is due to the complexity of the fishery, the lack of catch records by species, limited biological data, and unknown level of fishing effort directed towards Chondrichthyans in many fishing sites. And for all the mentioned above, the sustainable management of sharks and ray fisheries has been recognized as a global priority to ensure the conservation of commercially caught shark species, especially in the Mexican Pacific, the most important race and shark fishery in Mexico. To achieve the sustainable and management of Chondrichthyans in the Mexican Pacific or even in all Mexico is not an easy task. There are many challenges. And I say challenges because in the Fisheries Ecology Lab team at CICESE, where I'm currently doing a postdoctoral fellowship, we are working on many projects, focuses on the sustainable use and conservation of Chondrichthyans, developing projects to overcome these challenges. The lack of basic biological and fishery data is a major issue in many countries. Data poor or data limited fisheries around the world complicate the task of the scientists to find ways to achieve conservation and sustainable management for Chondrichthyan and many other species. In addition to this, there is a deficiency in the scarce information available. Through all the projects we have worked on, we have identified systematic weakness in deficits in the Mexican fisheries reporting system. In Mexico, the available official landings records have three major deficits. First, the historical catch Chondrichthyans landing records are not available for many years, with huge data gaps within years. Second, there is no differentiation between landings from the artisanal and the industrial vessel fisheries. And third, species composition data are lacking. In Mexico, landing data are compiled by the National Aquaculture and Fisheries Commission Central Office and reported annually through the Fisheries Statistic Yearbooks. Well, in these yearbooks, Chondrichthyans are not reported by species. Chondrichthyans landings have been reported under three main categories. Cazón, that means sharks of less than 150 centimeters total length. Tiburon for sharks of more than 150 centimeters total length. And rayas y similares, that means rays and relatives, whatever that relatives means, where chimeras are not reported, and it is not clear, however, chimeras are included in this category of rays and relatives, maybe, is unknown. Therefore, there is no catch per species in the official fishery statistics. Since the year 2000, more detailed fishery statistics by species have increased. However, there is still an average of 56% of unidentified species. In 2017, it was reduced to 44%, but still it is a high percentage of unidentified species. In addition, access to information is not easy. These statistics were obtained through the National Institute of Transparency and Access to Information, the INAI. That is a governmental agency that gives access to public information. In this particular case, we requested official catch statistics and that are supposed to be available for the general public to consult. Continue with this statistic obtaining to the INAI transparency portal. We also identified considerable increases from 2013 in CITES listed shark species such as the common treasure, the silky shark, the scalloped hammerhead, but it's not clear if this increase is due to the increase in the catches of these species or the fact that in the recent years the record at the species level has been improving. And we also found that other species such as the pelagic treasure shark, the smooth hammerhead, and the giant hammerhead are not reported in this official statistic, and we know the relative importance in artisanal fishery along the Pacific coast. We also detected inconsistencies in the land use reports between official sources. In the black line in this graph are the land use reported in the fishery statistic yearbooks that I mentioned before, and in the blue line are the landings in the databases that we managed to obtain through the INAI, and we clearly see how there are large differences which are not systematic, so we cannot think of a kind of conversion factor. These differences range from 7 to 37, indicating differences up to 10,000 tons between one source and another. This is crazy. In addition to the lack of catches by species, there is also no information regarding shark fishing permits. Information that could help us to have an estimate of fishing effort. In 1993, a moratorium of shark fishing permits was established to not issue more permits and thus to not increase the fishing effort for sharks. Through the NICE transparency portal, we were able to obtain a little information about the permits, and in 2018, 213 permits were issued for industrial fishing vessels. In the case of permits for artisanal fishing vessels, in 2018, 426 active permits were reported for more than 3,500 vessels. A permit can include one or more vessels, and we identify up to 178 vessels covered in a single permit. This lack of catch and effort data prevents that formal assessment of shark population in Mexico. Only 2 shark species have been assessed by international entities, the common treasure by the NOAA with Mexican scientists including in the analysis, and the shortfin mako by the International Scientific Committee for tuna and tuna-like species in the North Pacific. Both stocks are not overfished, and overfishing is not occurring. There are no specific management actions for these species in Mexico, only general regulations. The National Plan of Action for Management for Sharks and Rays was issued in 2004, followed by the emission of the NOM 029 that regulates shark fisheries in Mexico, including gear allowed and closure areas. And since 2012, a temporary fishing ban on sharks and rays was established. But the main issue is the lack of the enforcement for these regulations. Some specific issues for Mexican shark listed in CITES are the differences between the export data. CITES databases shows different value than those reported by different governmental entities, including the official Mexican CITES authority. Most of the requested and approved export permits came from Baja California and Nayarit, and surprisingly, no requests were received from Baja California and Sinaloa, from where we know fins and meat shipments goes out. Many producers have indicated discomfort with the duration of the permission process. All this, along with the number of shipments confiscated happening in the past years, make us believe that there is a black market of CITES listed shark products. And well, this black market could increase for the lack of training for personnel of custom in the country. We have 46 ports of exit where authorities cannot identify CITES species due to the lack of training in custom around the country. For this, CITES authority in Mexico, along with the Commission of the Environmental Cooperation, have training the authorities for the correct identification of these species, but it's not enough, and fast tools should be developed to aid them. Advances, we give us an idea of the great challenges that exist to achieve the Chondrichthyan conservation and fisheries management in the Mexican Pacific, including CITES shark listed species. So, how we have been working to achieve the conservation and management? Well, we have working on several projects using data limited approach, like catch reconstructions and ecological risk assessment. Depending on the available information, there are several approaches to evaluate the species. These semi-quantitative methodologies are used to assess species with few data. This means that when fishery is not enough data to carry out a robust assessment of the population, there are methodologies that allow us to use the lead information available to identify a relative vulnerability of the species to the fishery based on their life history traits, their productivity, and the interaction of the species with the fishery, called susceptibility. We have been assessing the vulnerability of fishing of many shark species, including CITES listed species. Currently, we are analyzing the productivity and susceptibility of several sharks and ray species in the Mexican Pacific. We also been reconstructing the historical catches of various species, and we followed the catch reconstruction rationally proposed by Pauli in 1998 of the importance of using all the available fishery data, as well as qualitative information to estimate and reconstruct historical fisheries landings. For this process of reconstruction, we review of the available historical catch records, we search for missing data components and for alternative information sources. Then we develop data anchor points over time to each missing data component. We interpolate time periods between data anchor points based on assumptions. Then we estimate the total catch time series, combining official catches and extending interpolated missing data series. And finally, we quantify the uncertainty associated with each reconstruction. Historical catch reconstructions has been carried out in various parts of the world, and some have become important component in robust population assessment, such as the assessment of the short-fin mako shark and the common treasure shark mentioned earlier. And with these catch reconstructions, we seek to solve the problem of the lack of catch data and the fishing records with deficits, and obtain information on the historical trends of the species and begin to explore the possible status of the population and the possible changes in species composition and abundance over time. Due to the huge data gaps and the great heterogeneity of the data sources and the difficulties to obtain data, we develop a way to use the qualitative information available and get the most of it. Here's an example of the reconstruction landings by species of artisanal fisheries for sharks in the Gulf of California. We graphically illustrate shark species composition and relative importance for each of the 5 decades from 1960s to 2010. And we create this table based on description of relative abundance found in the literature, including qualitative data, and each species was assigned to a qualitative category of high, that means a high frequency in the landings, moderate, that means intermediate importance in the landings, and low, occasionally captured or classified as bycatch only, or no record. Then a time series of landings of each shark species was created, combining this qualitative data with quantitative data. And this approach is the one that is the one we have been using for other reconstructions. Through the historical catches reconstruction, I had the opportunity to immerse in the historical context of shark fishing in the Mexican Pacific, and it's very interesting and it's a lot of information. Sharks have been part of the human diet since ancient times. However, the first commercial shark fishery in the present day in Mexico was not documented until 1880s, near La Paz, in the southern Baja California Sur, and the first shark fins were exported from Mexico to China in the 1888. And the direct target of sharks and in a more organized way began in the 1930s of the Pacific, on the Pacific coast of Mexico, and therefore the rules of today's shark fishery. Before the development of the synthesis of vitamin A in 1947, shark liver was the main source of vitamin, providing a boost to several shark fisheries around the world. The importance of the health and nutritious diet that include regular consumption of vitamins A and C was recognized by the USA Army since the World War I and during, of course, the World War II. Allied powers began to offer high prices to fishing communities in the Gulf of California for shark liver oil. The first shipment of liver was exported from the Gulf of California to Los Angeles in June in 1939, setting a fishery that lasted 11 years. Shark landings increased rapidly from there, and then landings decreased slowly to falling off almost completely in 1950s, when the demand of shark liver oil diminished with the start of the synthesis of vitamin A. Commercial shark fishing almost died in the 50s with this decreased demand for shark liver oil. However, in the southern part of the Baja California Peninsula, fishers continue to target sharks for their fins and meat, which they preserve with salt. To promote a greater national awareness of fishing products and opportunities, the Mexican government promoted the March to the Sea, starting in 1952, a program to support migration to the uninhabited coasts of the country and to develop fishing activities. This program accelerated the development of some coastal regions, and among other fisheries, shark fishing started to grow once more, although at a slow pace, mainly in the northwest Mexico. Shark landings from the Mexican Pacific coast increasing due to the development of shark fishing of the west coast of the Baja California Peninsula at the beginning of the 60s, and shark meat was incorporated into the diet of Mexicans during this time. And several typical Mexican dishes were based on shark meat. One example is fish tacos, which were made with braised slices of Pacific angel shark, Squatina californica, meat, and served at the Ensenada, Baja California fish market in the early 60s. During this period, shark landings rapidly increased, making Mexico one of the most productive shark fishing nations in the world. In the 80s, an economic crisis in Mexico impacted fishing operations for all species and harvest methods, and because the federal government withdrew supports to fishing communities, eliminating specific credits for the fishery sectors, and shark landings in the Pacific rapidly dropped. However, the private sector saw an opportunity in this period, and shark fisheries started their operation in Mexican Pacific waters, using large-scale long-line vessels to fish on pelagic species of the Mexican Pacific coast, targeting bill fishes with high incidental catches of blue sharks and shortfin mako. The other part of the fleet was based mostly in Manzanillo and operated along the central and southern Mexican Pacific coast. These vessels caught mainly treasure sharks, silky sharks, and hammerhead sharks. The federal government in this period created the Secretary of Environment, Natural Resources, and Fisheries, which implemented changes to encourage the sustainable use of fishing resources. These changes include the increment of public participation in the management process through the regional committees and the acknowledgement of the need of more scientific input and a reduction of fishing effort. And more recently, no new shark fishery is developed. However, the fishing operations cover a larger area of the high seas, almost reaching the limits of the Mexican Economic Exclusive Zone, and this expansion was driven primarily by medium-sized long-line fishing vessels targeting pelagic sharks. Well, we also working on catch reconstruction by species of the artisanal rice fisheries in the Gulf of California. For better understanding of how artisanal fisheries for rice has developed in the Gulf of California, and we identified that the average catches race estimated for the Gulf of California for a period from in 1997 to 2014 was the 63% of the total catch of the Mexican Pacific region, and for the national contributed with the 40%. In the Gulf of California, 34 species of rays are reported in the artisanal fishery. We identify the species with high fishery importance: the shovel-nose guitarfish, the specter guitarfish, butterfly rays, diamond stingrays, and Pacific condors rays. With this reconstruction, we begin to understand what happened in this fishery and with these species. And it's an alternative to analyze fisheries with limited data. If you think that reconstructing shark catches was difficult, the ray catches has been even more complicated, and we still continue working to improve these reconstructions. We also been obtaining data. Several deep water shark species and chimeras are distributed in the Mexican Pacific Northwest, and the interaction of these species with artisanal fishing has been reported. Nevertheless, biological and fishing data is even more scarce for these deep water species. These species have been reported more often in the fishing camp of Popotla, thanks to fishing surveys made in the Baja California fishing camps by the Fisheries Ecology Laboratory of the Dr. Oscar Sosa. And for all the above, we developed a project to describe the artisanal Chondrichthyan fishery at Popotla that we call Popotla Project for simplification, with an emphasis on deep water shark species and chimeras to improve the knowledge of these taxa and to create information needed to understand the interaction with the fishery and landing trends. Well, the study area in the Popotla project is the fishing camp Popotla, located in the northwest region of the Baja California Peninsula in Mexico. And this is a coastal zone near to Tijuana and the Mexican-USA border. And weekly surveys of the artisanal fishery at Popotla were conducted. And this is an ongoing project, but I will present some of the preliminary results. Well, several artisanal fisheries at Popotla are diverse and highly opportunistic. The main fishing gear are gill nets for fishes and traps for lobsters and crabs. The main target species throughout the year were swimming and spider crabs and bony fishes like lingcod, like scorpionfish, yellowtail, Garibaldi fish, halibut, Pacific bonito, and white sea bass. Sharks and rays species are bycatch, but the majority of the species are sold and consumed locally. These are mainly caught with bottom cell gillnets during all year, even during sharks and rays ban from May to July. We observed sharks and rays landings increase during the California spiny lobster season from September to February, when many fishers switched to lobster as target species and changed the fishing gears from gillnets to traps. 9 shark species were identified in the landings. The most frequent were the top sharks, the Pacific spiny dogfish, and the shortfin mako. We also identified the lopa sharks, the swell sharks, and mustelus species. We recorded 2 deep water shark species, the broadnose 7-gill sharks and the bloodnose 6-gill sharks, and 2 unidentified species. 7 ray species were recorded in the landings. The bar rays and the shovel-nose guitarfish were the most frequent, and 11 were unidentified species. Others observed species were the Pacific torpedo, the California scales, California butterfly rays, species from the Ipanus genera, and banded guitarfish. During the survey periods, 4 chimeras were recorded. Chimeras are retained and sold locally, but they are not target species. Some fishers even discard chimeras, but there is some demand, especially from Asian buyers. These species are probably not included in official fishery statistics. In another surveys from 2008 to 2010, 28 chimeras were recorded at Popotla, which indicates that fishing activities in Popotla have been interacting with chimeras for several years. Furthermore, in this fishing camp, it is also been reported deep water sharks like Echinorinus cookei and a species from the Eptomoridae family. This highlights the importance of the fishing camps to study deep water Chondrichthyan species, and the catches of these species most likely are not being reported. Other target species are 2 crabs and 1 shrimp, not identified, which are captured at more than 200 meters depth. This is not a legal fishery, hence the landings are not reported. Possibly it becomes an official fishery in the near future. So the fishing effort to deep water Chondrichthyan species could also be increasing. Popotla is not an easy place to do surveys. There are many illegal, unreported, and irregular fishing, and there is a lack of official fishery inspection and law enforcement. Many fishers do not want to collaborate with the service or provide data, and furthermore, it is a dangerous place with many illegal fishes activities going on there. But despite all this, we found exciting results, and we expect to create the baseline to study chimeras and deep water sharks in this region, and the interaction with the fisheries for food management plans and conservation. We have also been working directly with CITES scientific authority in Mexico to strengthen the scientific technical information available to support the in-source of non-detrimental findings. We developed a planning framework to improve the current knowledge of these species to secure the sustainable use. 6 guidelines were identified to improving the report system of fishing data, standardization of the biological and fishing monitoring, update the existing regulations, issuing of CITES permits, traceability and identification of transparency access to official data. And these guidelines were at different levels of stakeholders, from fishermen to traders, national authorities, and law enforcement. Well, in an unprecedented effort, we've been working directly with the CITES authority, fishing authority, academy, and non-governmental organization towards the sustainability trade of CITES listed shark species. CITES authority in Mexico hosted a workshop with stakeholders from all different sectors to define a plan to strengthen the scientific information that supports the mission of the non-detrimental findings. All the stakeholders agreed upon a critical road. This road includes 3 steps in the short, medium, and long term. First, the historical reconstruction of landings for CITES shark species. Second is the first assessment with poor data methodologies to finally do a formal stock assessment of these species. The reconstruction of the catches is an ongoing project that we developed along with the stakeholders right now. As you can see, there is still many challenges on the way, and there is still a lot of work to do. Some of the mentioned projects are still going on. We are still reconstructing historical catches of rays and CITES listed shark species. For the Popotla project, we are going to finish surveys and fisher interviews after a long break due to the COVID pandemic. And there are many projects in the horizon to continue obtaining information from monitoring, effectiveness, evaluation of marine protected areas, evaluation of vulnerability to climate change, Chondrichthyan monitoring in several sites in the Mexican Pacific, including, of course, deep water species, shark species. All these projects also include socioeconomic aspects of the communities inhabiting the places where we work. Also, we continue working in collaboration with different institutions and stakeholders, develop projects to create this link between scientists and decision makers to apply scientific knowledge to contribute to the Chondrichthyan conservation and fisheries management in the Mexican Pacific. With all this, I want to thank all the institutions that have collaborated in these efforts. Thanks to the financing, infrastructure, and support through all these projects and the future projects. And also I want to thank to all the collaborators, to Dr. Oscar Sosa for support and mentorship, for all the students, all the friends and lab mates that makes this project more easy. And well, especially to the Fisheries Ecology Lab for the opportunity to do my PhD and for all the great collaborations of many projects. I am thrilled for this opportunity to tell about the research efforts of the Fisheries Ecology Lab, where I work towards the Chondrichthyan conservation and fisheries management in the Mexican Pacific. And you can follow the official Cyber Seas Popotla project and my social media to find more about the progress of the project I'm currently working on, and I hope to give you more results and news soon, including science outreach for general audiences, which I consider an essential part of my work as a scientist. You can also follow my Twitter account to find about this and other projects. Also, you can follow my Instagram and Facebook account for scientific illustration, clay modeling with interesting facts about chondrichthyans. Also, you can spread the word about the Guild Guardians websites created by minorities in shark science with content to educate the general public about sharks, skates, and rays, biology and conservation, while engaging with women of color working in the field of shark science. You can find courses with videos, quizzes, activities, and more from all ages. And thank you so much.